Okay, so we're going to continue working on our review for the Unit 4 test. This is the 4.7 review worksheet. And we did a few the other day. We're going to continue and start with number 7. Like before, I'm going to mostly set problems up and have you do the calculating. So let's see how this works. Oh, I want that to go away. It says, what's the area of a parallelogram? So we could scroll up and look at the formulas. It's a parallelogram, so we need the base and multiply it by the height. So that's all we need is base and height. They give us the base here from B to C is our base 19. The height must be perpendicular to the base. That is the definition of a height. So they didn't put this in here, and they should have. So we're going to have to assume, which is a really bad idea, but for these purposes, I'm confident they intended 15 to be the height. It has to be perpendicular to the base in order to be considered the height. So let's make this a little bigger. The area of this parallelogram would look like the base 19 times the height 15. That's it. You're going to push the buttons on the calculator to get the final answer. Number 8, we have a parallelogram. This time they give us the area. Here we were looking for it. So we're going to use the same formula. Let's write it down. The area of a parallelogram is the base times the height. So we'll use this and plug in what we know, and we'll probably have a variable left to figure out what we don't know. They say the area is 115 square units. When we figure out area, we call it square units or units squared, or maybe if it's feet, we would say square feet or feet squared, depending on what the unit measurement is. If it's inches, we would say square inches or inches squared. But they say it's square units because we don't know the unit measurement. And the base, they tell us, is 12. So we have the base, we have the B, we have the A, 115. They want us to find the height. That's the variable that we don't know. So we'll plug everything in that order. We have 115 is equal to the base 12 times the height. And to solve for the height, excuse me, all we need to do is divide out that 12. So divide by, I'll move that in a minute. Oh, it's a little, I don't know what I hit that makes it do that sometimes, but obviously not the right thing. We'll make that a little bigger. I probably should have started by making it bigger. There we go. Make it look right. Okay, so we're dividing out the 12, and I'll let you push the buttons on the calculator to get the answer for height. All right, so again, for both of these, we used this formula, area equals base times height. Just in one of them, we were looking for the A value. The other one, we were looking for the H value. You got to solve it. Both of them I have not finished. You're going to finish them. 9 and 10, I don't feel like I want to set them up for you because we did them so recently. It's a parallelogram. And what we remember, I'll just tell you what is going to help you. Go to your notes, of course, but we remember that opposite angles in a parallelogram are equal. So 104 is equal to 2x plus 16. I'm going to let you solve that because it's not one we haven't done a few times and hasn't been that long. This one may be a little more tricky because they're not opposite and they're not equal. They are consecutive angles, and consecutive angles are not equal. They are supplementary. So I'll set this one up with you. 61 plus the other angle, 4x minus 20. Since they're supplementary, that means they add up to 180 degrees. So you're going to combine your like terms, and then you'll move that to the other side and divide by 4. Again, I'm not going to do a lot of the solving. You're going to solve. I'm going to help set up. Let's see what's next. Number 11. We also have done these very, very recently, but maybe I'll help set them up. The trapezoids can be a little more difficult. Because it's an isosceles trapezoid, that means the base angles are equal. And these aren't only the base angles. These two up top here, they're also considered base angles because the bases of a trapezoid are the parallel lines. So 82 is equal to 5x minus 40. In an isosceles, so you're going to set it up again. I'm not setting everything up because we've done them so recently. In an isosceles trapezoid, again, we could say these are equal down here. Angle D is equal to angle C. So this would be 2x plus 6 right here. Let's just type it in. I just kind of want to prove what I'm about to say. So we know this is 2x plus 6 because base angles are equal. But we also know because these are parallel lines, and we could consider this a transversal, these two are same side interior angles. And same side interior angles are equal when the lines are parallel. Since this is an isosceles trapezoid, AB is parallel to CD. Did I say equal? I didn't mean equal. Sorry, I meant supplementary. I don't remember what I said, but they are supplementary, not equal. So let's write it that way. We have 101 plus the other angle, 2x plus 6 are supplementary. That means they equal 180 degrees. I didn't use the right equation format, but I mean the tool, equation tool, I used the text tool, so it looks a little funny, but it's all good. Again, same side interior angles are equal. Gosh, why do I keep saying that? They're supplementary when the lines are parallel. Again, you're going to solve. I'm going to help set up. 13 and 14, well, 13, we most definitely did. I'll just kind of draw, because there's no diagram here. It's always a good idea to draw a diagram. Let's use straight lines here. We have a trapezoid, so let's draw some trapezoid. It doesn't say it's isosceles. We'll try to get as close as possible to parallel here and try to connect these and connect that. All that needs to be is parallel lines here. It says the base lengths are 18 and 40. And again, the bases are the parallel sides. So we have maybe 18 up here, and this one would then be 40. What is the length of the median? Well, the median is the line that connects the exact midpoint to the exact midpoint over here. And we might decide to call that X. And there was a formula we learned to find this, and that was the median is equal to, we took the sum of the bases, 18 plus 40, and we divided it by 2. And that'll get you the median. Move that over a bit. And I'm again going to let you do the calculation. Number 14, the area of a trapezoid. We haven't done that at all. So let's go back and look at our formulas. Here is the area of a trapezoid. It says it's half the height multiplied by the sum of the bases. 1/2 the sum of the bases divided by 2, or half of the sum of the bases times the height. When it's multiplication, which those three things are, we're multiplying by half, we're multiplying by height, we're multiplying by the sum of the bases. It doesn't really matter the order that we write them, but I don't want to confuse you, so I'm going to say the area is equal to 1/2 the height. Again, I kind of wish they had made it clearer that this is only the height if it's perpendicular to the base. And you might be saying, but wait, it's not even on the base. The base is over here. 19 starts here. Maybe it ends there. That's true, but we could take this unit measurement of 10 and we could draw it inside. It would still be 10. From the top to the bottom, it would still be 10. These two lines we might say are parallel. I mean, I tried to make them parallel. Oh, that's the district calling with some information. Anyway, if this line is 10 from the top to the bottom, this line is also 10. And if it helps you to see it inside to be considered the height, we could draw it, but it's not necessary. And this is also 10. Again, what I'm doing here isn't necessary. I'm just trying to help you see that that outside line, the line that is not even inside the trapezoid, it's still the height. So back to our formula, 1/2 the height multiplied by the sum of the bases. Well, the bases are 7 and 19. So we'll write those in as 7 plus 19. And you're going to calculate. I might do one step of this one for you to help you out. I want it to be the equation. So I'm going to take half of 10. Half of 10 is easy to do. That's 5. And we'll multiply that by 7 times 19. Not 7 times. 7 plus 19, which is 26. And then you just have to multiply and you're done. PEMDAS says do the parentheses first. So we could have done it in many, many steps. We could have done 7 plus 19 is 26. And then the next step would have been multiply left to right. And really, it doesn't matter. The order of multiplication doesn't matter. We could have taken half of 26 multiplied by 10, but I chose to multiply the half and the 10. You're not quite done. Multiply the 5 and the 26. That'll get us the area of the trapezoid. Alrighty, 15 is what I'm going to do next. This one is the area of the rhombus. And again, when I originally started to do this, I did some complicated work, but stop, don't make it too difficult like I did. The area of the rhombus is right here. It's 1/2 D1, D2. So D1 is the diameter of one of the diameters, and D2 is the other diameter. So that's super simple, assuming they give us that. I was all prepared to find extra information that I didn't need to find. They say, let me try to make this obvious here. We'll go red. They say that AD, oh, I meant it to be straight, whatever, is 14. AD, I'll try to keep my color coding. That whole thing, oh, this is going to get funny looking. That's one of the diameters is 14. That looks hilarious. It's going to be all messy. Hopefully my color coding will help. And then the other diameter, we'll make it pink, CB. Again, that whole thing is, do I have pink? Not really, kind of a purplish. Let's try to find that pink. That might be it. It might not be it. That one, CB, is 22. Okay. Those are the two diameters, D1, D2. And we need to take half of those after multiplying them. Or again, the order doesn't matter because all three will be multiplied. So the area is 1/2. Oops, no it isn't. Area is 1/2. D1, we'll call that 14. It doesn't matter which one is D1 and which one is D2. Times D2 is 22. And we could take half of 14, 7, and multiply by 22, or we could take half of 22, 11, and multiply by 14. It really doesn't matter. I'm going to take half of 14, and you are going to type that into your calculator to get the final answer. Okay, last one, I think. No, maybe. We'll look. Number 16 is the perimeter of a rhombus. Well, a rhombus has all equal sides. Let's make this a little bit smaller again So this is equal to this, which is equal to this, which is equal to this. They're 9 all the way around. I could write the perimeter equals 9 plus 9 plus 9 plus 9. Or I could make life simple and say the perimeter is 4 times 9. I'm pretty confident you can handle the rest of that problem. That's it. Perimeter, add the sides, or if they're equal, in this case, multiply by 4 because there are 4 sides. Let's see. I don't think I'm going to do this one so much as help you get started with it. And it's a rhombus. And if we look at our notes, the rhombus means that their diagonals are perpendicular. So that's a 90-degree angle. And this triangle has some information along with the 90 degrees where we could use triangle sum theorem. 90 plus x plus 40 plus 3x is 180. Same exact thing here. I'm not even going to set them up. We've done quite a few of these. Oops, that is not. That's supposed to be a 90-degree symbol, but it's a little bad. Okay, so 90 degrees here, plus 2x plus x plus 26 is 180 by triangle sum theorem for both of these. And I think we're done. Awesome. Okie doke. Good luck. You're going to kill it on the test. No problem.